Okay, so to find a vertical asymptote, first of all, you're dealing with rational functions, which basically look like fractions. But for vertical asymptotes, you're dealing specifically with the denominator. So there's two ways to solve it, algebraically and graphically. But in order to solve it algebraically, you're going to be looking at the denominator, and what you do is you set the denominator equal to 0, because you know the vertical asymptote is when this function cannot equal 0. So obviously, so you know that -3 is going to be your vertical asymptote, but you can check that by doing it graphically. So if you know that -3 is your vertical asymptote, you can graph that in. And then you can go to your calculator, and you plug it in, and then you graph it, and you see the graph looks something along the lines of this. And actually this calculator shows you that this is a vertical asymptote, but you can check it by going to the table, and you'll see when x is equal to -3, which is what we said the vertical asymptote is, there's an error. So that proves that the asymptote is there. Okay. You can do the same thing for a slightly more difficult equation. So once again, you're only looking at the denominator. And for this, you have to factor it first and set it equal to 0. So once you find the factors, and then x equals -1, or +1, and x equals -5. So these two are going to be your vertical asymptotes. You can have more than one vertical asymptote. So once again, you can prove this by doing it graphically, and you'll see at -5, you'll have an asymptote, and at +1, you'll have another asymptote. So you can also do this graphically on the calculator, and you'll see, and then you can graph it, and the graph will look like this. Since you know that there's two asymptotes, and it's dividing the graph into 3 separate parts, you know that the graph is going to have 3 sections to it, so you know your graph is correct. But you can go to your table again, and you'll see that, like you said, when x is equal to -5, there's an error, so that means that there is a vertical asymptote there. And when x is equal to 1, there's an error, so there's also a vertical asymptote there.